All right, guys, here we are again, solving inequalities, but this time we're interpreting the solutions. So let's jump into number 1. Given 2x plus ax minus 7 is greater than negative 12, determine the largest integer value of a when x equals negative 1. So a little recap here. Largest integer. So large we know means big. An integer is just any positive or negative number. Whole number, no decimals. So before we could do that, it says the value of a when x equals negative 1. And in the inequality given to us, I do see some x's. So what I could do is just substitute them in. So everywhere I see an x, there are some parentheses. And we're going to insert the negative 1 into those parentheses. And then everything else remains the same. So I have 2 plus a minus 7 is greater than negative 12. And now we're going to do just like we've been doing with inequalities, with equations. I'm going to draw a little bar down here. A little box around all of this. Actually, no, wait, pause. Before the box, we have to simplify here and simplify here. So I have 2 times negative 1, and that gives me negative 2. I have negative 1 times a, which is just 1a. So I have minus 1a minus 7 is greater than negative 12. Now I could go ahead and let's make my box. Okay, so I have the negative 1a here, I have the 2 here, the 7 here, negative 12 here. Remember, 2 and 7 flip signs because they cross the line. And then I'm going to take this and just continue here so we don't run out of space. So I have negative 1a is greater than, and we have to combine all of this, 2 plus 7 is 9, minus 12 is negative 3. My final step here is divide by negative 1, divide by negative 1. So far I know that a, and I have 3, negative 3 divided by negative 1. But remember what we said yesterday about the symbol, our golden rule. We had to divide by a negative, so that means I have to flip my sign. And now I know that a is less than 3. So let's go ahead and put that on the number line. I see a is less than 3. So here's 3. But is it an open or closed circle? It's less than, so it is an open circle. Less than 3, numbers smaller than 3 are to the right. So we are going to shade all the way to the right. And those are all my numbers less than 3. But that doesn't really answer the question. The question was to determine the largest number that is smaller than 3. So let's answer it. The largest number, integer, of a when x equals negative 1 is, well, let's see it. It can't be 3 because see here at 3 there's an open circle, so 3 is not in the solution. The next number in the solution is right here. It's 2. So the largest integer of a when x equals negative 1 is 2. So let's move on to number 2 here. It says solve algebraically for x. So let's go ahead and start solving like we would any other linear inequality or linear equation. First things first though, I see parentheses, so I know I need to multiply this negative 3 to both terms inside. So let's go ahead and write that next step out. All right, so now we're at this point, and now we need to simplify. So I need to simplify here and here. So negative 7 comes down with us. Negative 3 times 4x is negative 12x. Negative 3 times negative 8 is positive 24. Keep my inequality symbol and keep everything else. All right, next step, ladies and gentlemen, let's go back to our famous solving square. All right, I'm going to sort the terms by variables. We should be pros at this by now. And numbers. And I sorted like so. And now we need to combine like terms on the left and the right. On the left, I got negative 2x. On the right, I got negative 12. My inequality symbol for at this moment is just going to follow us down. Last step is dividing by this negative 2, dividing by this negative 2. So I have x, some symbol, and then 6. Negative 12 divided by negative 2 is 6. But now, once again, our golden rule comes into play. We need to flip the inequality symbol because we did divide by a negative 2. So x is greater than or equal to 6. And let's read part 2. If x is a number in the interval 4 through 8, state all integers that satisfy the given inequality. And let's explain how we determine those values. Remember, explain means words, but first, let's get the actual answer. All right, interval 4 through 8. So let's write those out. We have 4, 5, 6, 7, 8. And our inequality says that x has to be greater than or equal to 6. So here is 6. And all numbers greater than or equal to. So I'm going to just drop a little number line underneath this so we could see it visually like we're used to. So at 6, I'm going to put a nice closed circle because we're including 6 because it's greater than or equal to. And I'm going to shade everything bigger, greater than 6. So that's 7 and 8. I should actually take the arrows off of this because we are only stopping from 4 to 8. So this should be, oh, sorry guys. This should be a bracket here because this is where we're stopping on this side and this is where we're stopping this side. No arrows, we are not continuing. So now let's state the answer. So the answer is so 6, 7, and 8 satisfy the inequality in the interval 4 through 8 because 6 is included and 7 and 8 are bigger. All right, and that's that, guys, and I will see you tomorrow.